Hello and good evening, everyone. Welcome to Matholics. We'll be starting Human Eye and the Colorful World from the chapter of Class 10 Physics. Right. This is a chapter of Class 10 Physics, and we'll be starting the session in the next 1 minute. See, this is lecture number 3. Lecture number 1 and 2 already done. So, those are new. Must watch lecture number 1 and 2 also. Human Eye and the Colorful World, Class 10 Physics. Now, good evening, good evening, good evening. Good evening, everyone. We'll be starting the session in next 1 minute. In next 1 minute, we'll be solving PYQs, previous year questions from the chapter Human Eye and the Colorful World. I think, I guess, I hope you all are comfortable with myopia, hypermetropia. What are the reasons, what are the causes, and what are their corrective measures, corrections? Which type of lenses are used? I have told you already, right? So today we'll be discussing more questions. Good evening, good evening, good evening. Good evening, everyone. Good evening. Okay, so let's start the session PYQs for the chapter Human Eye and the Colorful World. Lecture number 3. Lecture number 1 and 2 already done. See, these questions we have done already. So you must have practiced. If not, then you are in a sincere, serious stage. Okay, these questions you must solve. All PYQs 2023, 2024, right? This question, I guess, we have done last. Question number 9, right? Bifocal lens, right? What are bifocal lenses and what is the disease or what is the imperfection which a patient must be suffering because of this? I guess it is nothing but what? Presbyopia. Yes, a person suffering from the defect presbyopia would actually use this kind of lens. Yes or no? Okay. So let's move forward towards next question. Question. What is the question? Derive the term dispersion of white light. State the color which bends the most and which bends the least while passing through a glass prism. Draw a diagram to show dispersion of white light. Right. Now, for the correction of this kind of, for the correction of this kind, not correction actually, for dispersion, at least 3 to 4 marks question is expected. This is from CBSE 2023. So when a beam of light, white light enters a prism, it actually gets refracted at a point, yes or no? And through refraction, it splits into 7 colors, that is from violet to red. Vibgyor, Vibgyor. Yes or no? Yes or no? Vibgyor. Okay. So focus on this diagram. Let me correct some focus over here. Okay, I think everything is going smooth now, right? So we can start the session now. Down session will be coming very soon, don't worry. Okay. So the light actually breaks into Vibgyor, Vibgyor. It splits into 7 constituent colors, and those colors are namely Vibgyor, Vibgyor. We'll see how it actually goes through this prism. Okay. Now the color that bends the most is violet, and the least bending is in red. Okay. So see, this is how it is actually bending. A ray of light is coming like this. Okay, it's coming like this, right? Now it's actually bending. What happens inside a prism? Let me tell you. See, Say if this is a glass prism, okay, right? And a ray of light is coming like this, okay. Now tell me, now tell me that, wait, okay. If a ray of light is going from, this is rarer or denser? This medium is rarer medium. Inside medium is denser. Yes or no? Glass is obviously denser than air. So this is the normal. Yes or no? So the light will bend away from the normal or towards the normal. Anyone in the comments? Anyone in the comments? The light will bend away from the normal or towards the normal. Tell me. If a ray of light enters from rarer to denser, obviously that speed will be lowered down. So it will bend towards the normal. It will bend towards the normal. Okay. So it will bend like this. The final bending will be like this. This is the direction. See, this is the direction of light initially. Yes or no? So it will bend towards the normal. Away from the normal would be like this, right? So it's not going like this, it will be going like this thing. Okay. So this is bending away from the normal, bending away from the normal. Now again make a normal. Normal means the perpendicular to this line. Now the ray of light is this blue ray. It is going from denser to rarer. So this is the initial direction of the ray. Yes or no? Yes, sir. So it will bend away from the normal. It won't go like this. It will go like this. Got it? Yes or no? Tell me. It will go like this. This is the direction of normal. This is direction of normal. This is ray of light. So obviously it will bend like this and it will be going like this. So this is actually what is happening inside the prism. Got it? Normal is nothing but the perpendicular to the surface of prism. Okay. Got my point? Rarer to denser and denser to rarer. What actually happens? If it goes from rarer to denser, this is the direction. You can make it again. You can make it again to get a clear vision of all this. See, this is the direction of light initial. This is the normal perpendicular. This is the normal perpendicular. Okay, sorted. Yes. So this is how actually it bends when it goes from rarer to denser. As we can see, this is the normal and this is the perpendicular. Okay, so this is the normal. This is the direction of light. So it actually bends towards the normal. Away from the normal would mean it would be going from direction this to direction this. This direction is away from the normal, right? It is towards the normal, and now it's going like this. Now my incident ray is this. So this was the incident ray. This was the refracted ray. Now this is the incident ray, and this will be the refracted ray. So this incident ray again. This is normal. This is normal. So this angle is what, 90 degree? Yes or no? See, this angle is 90 degree. Yes or no? Yes, sir. Because this was the normal, and this is the direction of light. This horizontal direction. So in this direction, will it bend towards the normal? It will be like this. It will bend away from the normal. That means because it is going from denser to rarer medium. Denser to rarer medium. Okay. Do not talk amongst yourself, else please leave from the class. Okay. So this is how it gets refracted. Okay. So now this refraction is obviously according to their wavelengths, their frequencies. You must only remember for now that if it is Vibgyor will be from lowermost level to uppermost level, right? It will be like this. Wait, let me draw it. Vibgyor, Vibgyor, right? And the bending is maximum in violet. The color that bends the most is violet. Maximum bending. See, maximum bending. See, yes or no? Is it true or false? This is maximum bending in violet, and upper side is red. That means minimum bending is red. Yes or no? I guess it is very much clear. Sorted. You must copy this. This diagram you must copy this. This diagram you already must be having in your books. This you must copy. Must copy this diagram. Copy this. Try to draw. Try to draw yourself. Try to draw yourself. Okay. Giving you 1 minute. Copy this. Copy, so we can move forward. If done, so we can move forward. Okay, let's go. So this was the basic question which actually comes as it is in your exam, right? So you must write Vibgyor starts from lower level. From downside, it is Vibgyor violet. Then it starts to like this: violet, indigo, blue, VIB, violet, indigo, blue, GYOR, green, yellow, orange, and red. Okay. So yellow, orange, red is the last one. Done. So we can move forward. So this is how the dispersion of white light is carried out inside a prism. And outside the prism, what happens? We have seen Vibgyor, VIBGYOR. The maximum bending is in violet. The minimum bending is in red. Okay, so let's move forward. Now, next question. Where is next question? Oh my God. Next question is on your screens. Will come now. We'll see to take otherwise or some different question. Okay, let's see this question. Again, formation of a rainbow. How a rainbow is formed actually, right? This is also example of refraction only. Dispersion of light. Okay, this question we are going to discuss. Every question is beautiful, in this question bank. Every question is like you just have to solve these questions and you are good to go in for your exams. Okay, let's move forward. Now, what the question says, see, draw a labeled diagram to show dispersion of beam of light. Same diagram you have to draw, but mark. Actually, you must remember one thing. If a light is going like this, now, if a light is going like this, you must actually draw the direction of light which it was actually coming. Right. This is the direction of initial light. Right. So it will bend. Obviously, this is the normal. Right. See, if this is the normal. Wait. So if this is the normal, see, so this is the perpendicular, right? This perpendicular. So obviously, you don't have to draw. See, perpendicular will be drawn like this only. Any other option to draw the perpendicular? Tell me. Any other option to draw the perpendicular? This is the perpendicular. Okay, this is the perpendicular. So this is the direction. So it will move what? Towards the normal. And towards the normal will be what? Somewhat like this. Towards the normal, right? This will be called away from the normal. Sorted. Sorted, yes or no? Oh, any other perpendicular? Perpendicular can be drawn like this also, not like proper perpendicular. So this is the proper. See in the last diagram which we have done. The last diagram was this. See how we have drawn the perpendicular like this. Okay. So in this diagram also you must draw. If you actually wait, you actually remove this blue line, you must come to know that where will be the perpendicular. Tell me. One way is to draw perpendicular like this. This is the only correct option. This is the only correct option like this. Okay. This is the perpendicular. Draw a perpendicular line. So this is the perpendicular line. Yes or no? Yes. So if this is the perpendicular, you must actually draw only to the upper side. Only till the upper side. This is the perpendicular. Okay. If the normal is like this, away from the normal would mean what? This, if this comes towards this direction, it is towards the normal. It is away from the normal. Or we have to draw like this, which we have done in this diagram. See, this was the perpendicular. Yes, this is the perpendicular. All depends on the ray of light, how you have actually to sort it. So now what the point arises, sir, how to make actually this diagram? How to make this diagram? See, this diagram is incident ray is somewhat lower, right? In this diagram, incident ray is like this, okay? So this is, see, you have to draw the perpendicular. You have to draw the perpendicular towards this surface. Again, I am drawing, so kindly focus. Again, we'll draw, okay. Let's do one thing. Again, draw. You must actually know how to draw this diagram. If this diagram is not perfect, now forget about everything. You are not able to even draw the diagram neatly, clearly. This is actually having marks, 3 marks, 2 marks, this diagram. So you must practice this diagram, okay? Sorted, sorted, sorted. You must actually write, if you are saying about Prashant sir, you must say Prashant sir. He's not your friend, okay? So kindly leave from my class, you idiot. Okay, now actually try learn to give some respect if any teacher you are talking about, okay? So first draw perpendicular. If I draw perpendicular, see this is the perpendicular line. If I'm right, if I'm right, let's say this is the perpendicular line. This is the perpendicular line. Okay. And this is the direction of what? Incident ray. Okay. Now focus on to this point. Now focus on to this point. Now this is the direction of incident ray. Obviously from rarer to denser. This is rarer medium. This is rarer medium. This is denser medium. Yes or no? And if this is denser medium, obviously it will move towards the normal. Okay. It will slow down. The ray of light, speed of that ray light will be slowed down. That's it. So this is the direction. And it will go like this, and from denser to rarer. If it is denser and it is rarer, okay. So let's make the normal. So perpendicular is this. Okay. See, you can see the diagram. If this is perpendicular, right, this is normal. It is going away from the normal. This ray of light is going away from the normal. See, yes or no? So this is how actually diagrams are made. This should be seen perpendicular. This is perpendicular like this. You must draw the normals also, right? Can we move forward? Yes or no? Sorted. So this is actually diagram. Now this diagram is actually having weightage, and sure you will get 2 to 3 marks questions for this diagram. So this is VIPCure. How it is made? Like this. Then just you have to make different 7 different refracted rays inside. 1, 2, 3, 4, 5, 6, 7 like this. Okay. This is 1, this is 2, this is 3, this is 4, 5, 6, 7. They all are going like this in this direction, right? So for this ray, actually this is the perpendicular, yes or no? And from denser to rarer, see, approximately it will go away. It will be again bent away from the normal. Okay. So that's the way you actually make diagrams. Every line, see for this line, if this is the perpendicular, okay, this is going away from the normal. This direction is what? Away from this line. This direction is away from this line. That's it. That's what we call away from the normal. Okay. That's it. Nothing to worry about this diagram. Okay. Now dispersion of beam light, we already formation of a rainbow. Now comes on. Draw a labeled diagram for formation of a rainbow. See, this is the sunlight. White light, this is a sheet with a pinhole. Obviously, this white light comes, this is a sheet, and this is having a pinhole. See, this is important point which we have missed actually. You have to make this sheet. How white light comes? There is a light, there is a sheet. Inside that sheet, in between of that sheet is a hole. From that hole, light is passing to this. Light is actually going incident on this prism. Okay, sorted. That's it. This is what I was saying, that you must know actually what are essential for the diagrams. Okay. Now, formation of rainbow. What actually a rainbow is having? See, this is sunlight. This is raindrop. This is the droplet of water, rain which is coming, right? This sunlight actually goes to this circular spherical drop. Okay. Now this is rarer or this is denser? This is obviously rarer. Okay. This is rarer medium, and inside this is denser medium. Okay. So what happens? What happens? Can you tell me? Yes, the ray of light goes towards the normal. And what's the normal for this denser medium? This is the center. This will be the normal. You make a tangent over this. This is a perpendicular to this surface. So see, if this is the normal, this is the normal, this is the normal n, this blue line. Can you see clearly that this ray of light, can you see that this ray of light is actually bending where? This was the direction of light. See, this was the direction of light initially. Light was going like this. Okay. You make a dotted line. See, this was the direction. So it actually bend towards the normal. See, this is the normal. Ray of light is going like this. It bends towards the normal. Okay. So it is going like this. Fine. Yes or no? Yes or no? It's going like this. Okay. And when it goes like this, it actually again gets refracted. Now this is the same medium that reflect. It actually happens just as a mirror. So the angle of I equals to angle R. So this is going like this. Yes. Now this is from denser to rarer. Yes or no? And denser to rarer, what happens? Away from the normal. Normal is this. You draw like this. This is a tangent. Yes, sir. Right? As this was the tangent, this is a tangent. And if you focus on to this point, if this is the normal, this is the normal line. Okay. It is going where? Going where? Denser to rarer. Denser to rarer means away from the normal. See, this is the direction of normal. If this is the direction of normal, the ray of light is going like this. Ray of light is going in this direction. See, that is actually away from the normal. Yes or no? Going somewhat away from the normal, right? So that's how actually we make diagrams. Okay. Is it clear? So you must, can I copy those to which you have made changes? Yes, yes, yes. Copy, copy, copy. So these two diagrams actually you must copy. These two diagrams you must actually copy. Okay. The changes are just for understanding. For your exam overview, you just have to remember the main diagrams only. These changes are actually for understandings. Okay. You must actually draw these diagrams. This is going like this, going like this, like this, like this. Okay. So you must know actually how to draw the diagrams. That's it. Okay. These both diagrams you must copy, then we'll move forward. This is what actually happens uh, in a rainbow. And this is what, see, now see what I'm doing. See, I'm removing these lines. I'm removing these lines. Need not to draw these lines. This will make the diagrams messy. That's what only, that was only for your understanding purpose. Okay. Now see, you just focus that this is rarer and this is denser. This is like, this version is going like this. See, this is denser to rarer. What was happening in white prism? That was from rarer to dense. See, denser to rarer, it is actually Vibgyor. Red on the upper side, same it will happen Vibgyor, right? Same it will happen like this: Vibgyor. This is the order of the colors, right? You always see the red color over to the top and violet over to the lower portion. Yes or no? So this is actually happening same. Instead of glass prism, it is water droplet. Okay. So now you can copy this. Done, done, done. Can we move forward? Yes or no? I guess it's done now. Okay, let's move forward. So this was the question. What happens inside a rainbow? Rainbow diagram important. Dispersion diagram important. That's it. This same questions you have to practice again and again just to be sure to grab those 2 or 4 marks in your exams. What is a rainbow draw label diagram? Okay, this is just you have to write what is actually memorizable. The rainbow is a natural phenomenon in which white light splits into beautiful colors by water droplets, which remain suspended in the air after the rain. It appears as a circular arc of various hues with violet on the inside and red on the outside. Only when the sun is behind the observer and the rain is in front of the observer can a rainbow be seen. Yes or no? Sun is actually that side and rain droplet is here. Okay. Green is okay, that's it. Red, orange, yellow, green, blue, indigo, and violet are the 7 colors that make up rainbow Vibgyor, and they are arranged from the outer to the inner edge. And do not forget to make the diagram like this. Do not forget to make the diagram. Beam of light is coming, rainbow is there. Okay. Refraction takes place like this. Okay. When the observer is on the ground, it is red. First visible red, then violet is on the inside. Okay. So that's how you must make. Now this diagram and this diagram is same. Actually, this is what the observer feels. Okay, this is the observer. Now, which defect of the eye is known as farsightedness? When does this defect arise? State two reasons. Farsightedness means what? Long-sightedness, hypermetropia, long spelling. You must know this, every one of you. Yes or no? I guess yes. So that's how actually you must learn to write what actually is effective for your exams. Okay. So when does this effect arise? You actually know eyeball becomes hypermetropia, long swelling. Eyeball becomes smaller, it contracts. An expansion of eyeball, largening of eyeball is in case of myopia, yes. And next question is state two reasons. One was eyeball became smaller and focal length of eye lens becomes large. Okay, focal length becomes large. Okay, done. And how is this defect corrected by using concave or convex lens? You all know by using a convex lens that is thick from the inside because we cannot see nearby objects. For reading newspapers, you are actually using a thick lens. Okay, I've told you numerous times. Okay, that question is gone. One is okay. This is also a point to be mentioned that the hypermetropic defect arises when the near point for the person is near point is what? It is farther actually, right? When the near point for the person is farther away from the normal near point 25 centimeter. What is the near point? Near point is that to that point you can see clearly, right? And this near point is what? Near point is more than 25 centimeter. You cannot see that object. Yes or no? Okay. Far point and near point. Okay. For that it is far point and for this it is near point. Okay. So actually you must learn these terms. What is near point? What they are saying, see, this defect arises when the near point for the person is farther away from the normal near point that is 25. If this point is actually to that point, okay, so I cannot see that properly. Okay, that's all. Differentiate between a glass slab and a glass prism. Prism has two inclining surfaces, whereas a glass slab is like this, straight. Okay. And what happens when a rainbow beam, what happens when a narrow beam of a monochromatic light and white light passes through a glass slab and glass prism? Okay, this you must remember that when monochromatic light passes through a glass slab, it gets displaced literally, whereas in prism it gets angularly displaced. Yes or no? It gets displaced laterally. Laterally means like this only, and it is displaced angularly like this only. Okay, so when white light passes through a glass slab, it gets laterally displaced, whereas in prism displacement takes place. Okay, same point. Tyndall effect, you must, this is one line question, you must remember this. These questions you actually need to focus. Now, what is power? Power is actually 1 by F. You must know this, right? This question we can do a long answer type question. This question we can do from question number 19th. Okay, okay, question number 17th we can also do. Question number 17th we can do. 17th, 19th, and 20th. This we will be doing. Okay, read this question. Let's solve this. What does the question? A student, what the question says, see, a student needs spectacles of power minus 0.5 D for the correction of his vision. Okay, no problem. Power is what? Power is minus 0.5 diopter. Okay, D is what? Diopter, unit of power. Name the defect in vision the student is suffering from. So first we'll know F. F will be what? F will be, sorry, P equals to 1 by F first, right? Okay, P equals to 1 by F. So F will be 1 by P. Okay, that is 1 by minus 0.5. Point gone into 10, it is 2. That means it is 2 meters. Focal length is 2 meter minus negative. That means F equals to minus 200 centimeters. Yes or no? Focal length we calculated. So focal length is negative. Focal length is negative. What kind of lens it must be? Tell me. Name the defect in vision the student is suffering from. Obviously, minus. That means myopic vision it will be there. Yes or no? So since power of spectacle is negative, therefore student is suffering from myopia. Myopia means long distance is not visible. Near one objects are visible. Long sightedness. Sorry, short sightedness. Shorter ones are visible. Longer distant objects are not visible. That means that's why the power is negative. And concave lens of focal length 200 centimeter used. Why? See, concave lens is like this. Yes or no? This is concave lens. Yes or no? So this is the axis. Obviously, you know that this is happening. This is happening. Light is going like this. So focus will be somewhat at this point. So focal length will be negative. You all must know that concave lens, if it is used, then focal length is negative. That way also you can answer. This way you can also answer. Yes or no? I guess this is very much clear to everyone of you. Is there any doubt in this concept that focal length is negative? Focal length is negative. That means the lens which will be used will be a concave lens. And negative focal length, you can, power is negative. Positive power is where? Positive power comes when a person is not able to see nearby objects. That means hypermetropia. Okay. Negative power means long distance objects are not visible. Near ones are visible. Okay. So since power is negative, therefore students suffering from myopia. Concave lens of focal length this is used. What causes? What are the causes? Causes of this defect: excessive curvature of the eye lens. Yes or no? I told you myopia, elongation of eye lens, you can say, or excessive curvature eye lens, and elongation of eyeball. These are the causes. Okay, I guess it is clear. Moving on to next question. I guess 17 is done now. Moving on to next question. Okay, it's correct now, I guess. It's almost good now, if I'm right. Anyone in the comments? All is well now? All is well? Sorted, sorted. Now everything is going smooth. Yes, everything is going smooth now. Okay. Now see. Question says, name two defects of vision. You must know myopia and hypermetropia. What is the third defect? Can anyone tell me? Presbyopia, having both type of defects. Yes. Now see. Question is, mention two main causes. What are the causes? First is myopia. First is myopia. Myopia. The main cause is what? For myopia, the main cause arises due to following reasons. First one is excessive curvature. I again and again I am telling you elongation of eye lens or excessive curvature of eye lens and elongation of the eyeball. One or the same. Now presbyopia. Oh, sorry. Second is hypermetropia. For hypermetropia, what happens? Focal length of the eyeball increases, eyeball is shortened. Eyeball is shortened and focal length is increased. In myopia, focal length is decreased, I guess. Okay. Sorted. Yes, obviously yes. Okay, can we move forward? Tell me, what happens to the focal length in myopia and hypermetropia? In myopia, yes, the eye has a shorter focal length. Myopia, shorter focal length, but elongation of the eye lens. In hypermetropia, contraction, smaller size, eyeball is shortened, but the focal length is increased. Yes or no? Yes or no? Hypermetropia, the eye has a large focal length as compared to normal eye. Yes or no? So these are the different points you must write. Yes. Done. Fine, I move forward. Sorted. Okay, let's move forward. Second part. See what the question says. The second part. Important. A person uses spectacles having lenses of focal length minus 2.0. So minus par means it is having myopia, long vision objects. Long distance objects are not visible. Okay. Determine the nature and power of the lenses used in this spectacles. Same. Nature will be what? Tell me. It will be concave lens, obviously, and focal length is negative. So person will be suffering from myopia. Yes or no? They are saying this nature and power. What is nature of lens? Concave. Power 1 by f. That means 1 by minus 2.0. Right? 1 by minus 2. 1 by minus 2. That will be minus 0.5 diopter. Always remember this. Always remember this. That unit of focal length while while calculating power while calculating power must be in meters. Okay, must be in meters. If power is actually power formula is actually 1 by f, this f has to be in meters. Okay, this is to be remembered, and this question can come as it is in our exams. Okay, got it. So this was another type of, I guess every part aspect of this chapter is done now. We can see again. This is the question. Okay, question number 19 is this 20. State the role of ciliary muscles present in our eye. I already told you that. What is the role of ciliary muscles? Tell me. Identify this. We'll read later. For ciliary muscles hold the lens in position and help in modifying the curvature. Therefore, ciliary muscles in the eye can increase or decrease the focal length, right? As if the pupil has to control for the light coming into the eyes. Ciliary muscles actually control the focal length, increasing and decreasing of focal length. Okay. Next is identify the defect of vision in each of the following cases and suggest its corrective measure. The eye lens has become milky and cloudy. Milky and cloudy means cataract, motiabund, है ना? Motiabund in Hindi we can say. Cataract, and it can be corrected by surgery, obviously. Okay. The eye lens has excessive curvature. Tell me B. Eye lens has excessive curvature. Myopia. B. Myopia. Corrected by using a concave lens. I'm so sorry. Third one is the eye lens has large focal length. Large focal length means hypermetropia. Large focal length or smaller eyeball size. Okay, large focal length, hypermetropia obviously, and corrected by convex lens. Ciliary muscles have weakened. Weakened means what? If ciliary muscles are weakened, it cannot. What happens when ciliary muscles are weakened? We have done this question before also. When ciliary muscles are weakened, they cannot control the increment and decrement in focal length. Yes or no? And when the focal length is not controlled, presbyopia happens. That means myopia and hypermetropia both. presbyopia, and it can be corrected by using a bifocal lens. Okay, this we have done already. So that's it. This is it for this chapter, human eye and the colorful world. I guess you all must have enjoyed these classes. These were actually 3 sessions, approximately 15 to 20 questions we have discussed. So if there is any doubt, you can comment later on also. That is it for today. It's time for me to say goodbye to all of you. Tomorrow we'll be starting triangles, right? PYQs. I guess triangle basics you must have done in your schools. We'll be solving good questions. At least 25 to 30 questions we'll be solving in 3 to 4 lectures. It will complete triangles. Okay. So that's it. Good night. Take care. Bye-bye. See you soon tomorrow.